Okay, so this is the last question that we did not cover. I'm just going to talk you through how to answer it. So basically, they're saying the molar mass of a hydrated sodium carbonate is found to be 268 grams per mole. The formula of the hydrated sodium carbonate is Na2CO3, and then we've got this funny little dot here, and then you've got an X, H2O. And we'll come to that just now. The question says, calculate the number of moles of water crystallization, which is X, this value here, they are the same, in the compound. So you might be asking, what is water crystallization? And basically, there are certain salts that like water quite a bit, and therefore their molecular structure exists with water molecules as part of it. So here you can see that water molecules forming an essential part of the crystal structure of some compounds. And it actually sometimes gives them different colors. For example, copper sulfate, when it is hydrated, is blue. When it is anhydrous, it is actually white. So it is a necessary part of our formula, because you will see that water is going to therefore increase the molecular mass of the entire formula, because it forms part of the formula. But there are a certain number of moles that actually make up this section of water, so in a specific ratio. So how do you go about finding X? So going about finding X should be relatively simple. Or first thing that you need to do is you need to find out how much is the molecular mass of the water in itself. So there are three components. There's the molecular mass of water. There's the molecular mass of the hydrated salt. Okay? And there's the molecular mass of the salt in its anhydrous form, which is obviously without water. So the molecular mass of water is really, really simple. As you can see, it is 2 hydrogens, so it's 1 times 2, plus 16, which is the atomic mass of oxygen, and that gives you 18 grams per mole. And if we have to calculate the molecular mass of sodium carbonate, sodium is, and if I have to just take a look here quickly at my periodic table, sodium has a molecular mass, or atomic mass of 23. So there we go, right to the end. That's 23, times 2, because there are 2 sodium atoms, plus 12, which is the atomic mass of carbon, plus 16 times 3, because there are 3 oxygen atoms. I'll just take that in my calculator quickly. So it's 23 times 2, plus 12, plus 16 times 3, and you find the value to be 106 grams per mole. So the molecular mass, they have actually given to us 268 grams per mole. All right, and I'm just going to move this one side, grams per mole. So essentially this 268 grams per mole is made up of 1 part sodium carbonate anhydrous, and then X part of water. So if we have to just draw ourselves a ratio, so you've got the anhydrous, and then you've got H2O. So the anhydrous we've already calculated to be 106, and H2O we already know is 18. However, the total amount is equal to 268. So if I say 106 plus 18, it does not give me 268. I cannot multiply my sodium carbonate. I in fact have to multiply my water. So I need to find out how many 18 grams per mole I must now add in order to give us a total of 268. So if I just come here and I say, well, let us take out 268 and just subtract the 106. That is the anhydrous. So 268 minus the 106, and that gives us 162 grams per mole of water. This is how much, this is the weight of water that is remaining. Because remember, it is 268 for the hydrated sodium carbonate. Only 106 makes up the sodium carbonate. So the hydrated part is what is remaining, which in this case is 162. Remember that the molecular mass of water is actually 18 grams per mole. So how many 18 grams per mole exist in 162 grams per mole? So that should be really, really easy to do. You just say 162 divided by 18, and that should give us our value of 9. So there are 9 times water molecules, sorry about my dogs, molecules, for 1 anhydrous, and again, forgive my spelling, anhydrous salt. And that would mean that our formula would actually be Na2CO3, and X is now replaced by 9H2O. And if we have to do the calculation of molecular mass, we should find the value should be 268 grams per mole, given that that was what they told us the molecular mass is for the hydrated sodium carbonate. All right, so I hope that was easily explained to you. And if you have any problems, just let me know. Thank you very much.